6 trig functions coming at you. Until now, you might have thought there were only 3, but in fact there are 6. We have cosecant, which is the reciprocal of sine, secant, which is the reciprocal of cosine, and we have cotangent, which is the reciprocal of tangent. So, what we're going to do is first start out by looking at your 4 quadrants, just so you know that in quadrant 1, sine, cosine, and tangent are always going to be positive, because remember, sine is y, cosine is x, and tangent is, well, sine divided by cosine, or y over x. Since over here on the left, this is when you have a negative x and a positive y. That's why sine is the one that's positive and cosine is negative. In quadrant 3, tangent is the only one that's positive, because sine divided by cosine, or negative divided by a negative, is positive. And in quadrant 4, cosine is x, and this is the only place where x is positive and y is negative. So that's why we have cosine being the only positive one. Also remember, sine squared plus cosine squared is equal to 1, our Pythagorean identity. So we're going to use a whole bunch of this stuff to talk about some new types of problems. Now the first thing I'm going to do is show you how to prove that the tangent of theta is equal to sine over cosine. And we just use good old-fashioned, old-school geometry, where we're going to use similar triangles. So we have the little triangle. We know that x is always cosine, we know that y is sine, and we know that our radius is 1. Well, if we redraw, remember, a tangent is a line that just nicks the circle once. So we just expanded our triangle to where this is now your radius of 1. We have a hypotenuse, and now we have our tangent. Using similar triangles from back in the day, all you have to do is set up the ratio. So we know that using similar triangles, we have sine over tangent is equal to, and then we go to cosine over 1. And of course these are all thetas, so we can just cross multiply, and that's going to give us tangent of theta times the cosine of theta is equal to the sine of theta. Get tangent by itself and you end up with the tangent of theta is equal to the sine of theta divided by the cosine of theta. Done. Proven. Now you can see for sure that's the way it goes. So, using that same type of philosophy, I would like you to find the secant of theta using similar triangles. It's already drawn for you. It's very similar to the one you just saw. I want you to find the secant of theta. Go for it. Give it a try. There you go. It was just 2 steps because we know the secant is 1 over cosine. All I needed to do is show it using similar triangles. So you set up your similar triangles. We have cosine over 1 is equal to 1 over secant. So we set it up like this, and since we're looking for secant, the only thing we had to do is take the reciprocal of both sides. So we flip them, and secant is equal to 1 over cosine. Done. Now that you know that, let's put this stuff all to work. So we're going to find all the trig functions. Now, the thing is, you're going to have to be careful. Maybe give yourself a quick sketch so you make sure that you are in the correct quadrant when you are answering these questions. So let's just do this really quick. We're going to say that the cosine of theta is 4/5, but the tangent is less than 0. So if you go all the way back to the beginning and think about that, or you can just think about it this way. In which 2 quadrants is cosine positive? Well, since cosine is your x, cosine is positive in quadrant 1 and quadrant 4. So in which quadrant is tangent negative? Tangent is negative in quadrant 2 and quadrant 4. So the only one they have in common is quadrant 4. So this diagram needs to be drawn in quadrant 4. So we have our theta. Now cosine, if you remember from back in the day, geometry, cosine is adjacent over the hypotenuse, so that makes this 4 and your hypotenuse 5. So now all you have to do is find this guy right here. And we use a little bit of Pythagorean theorem. 4 squared plus b squared is equal to 5 squared. So 16 plus b squared is equal to 25. B squared is equal to 9, so b is equal to 3. But because we are in quadrant 4, you need to remember that that is a negative 3. So now you have to find all 3 trig functions. So we have the sine of theta, the cosine of theta, the tangent of theta. And the sine is opposite over hypotenuse, so negative 3/5. The cosine of theta we know already because that was given to us, 4/5. And then tangent is opposite over adjacent, so we have negative 3/4. So then we just have to find the other 3. So cosecant of theta, secant of theta, and cotangent of theta. And to get those, we just take the reciprocal of the original 3. So this is a negative 5/3, this is a 5/4, and this is a negative 4/3. And that's it. You just found all 6 trig functions when given 1 and a quadrant. All right? So the last one is all you. I'm giving you that the secant of theta is 13/5, and I'm telling you that the cosecant is positive. So draw a diagram, label your 2 pieces, find the 3rd piece, and list all 6 trig functions. Give it a try. And check it. Since you knew that the secant was 13/5, when you drew the picture, you just think about cosine, which would be 5/13. So, of course, we have these 2 already. Use the Pythagorean theorem to get 12, and just put all the pieces together. And that's it. That's how you use 1 trig function to find all the other 5. This is Longo, and I'm out. See you, bye.